Hello, and welcome back to the Ninox Learning Channel by Nioxus. My name is Andy. I'm a Ninox programmer and trainer with Nioxus Corporation. And in this class, we're going to look at how we can leverage and use data in child tables and in the tables of other stacks or families in our data model within the current screen of the Ninox application that we're building. We're going to look at how paths allow us to get from where we are to where the data is that we want to use in our calculations. We're even going to take time and quickly build a dashboard. This class is going to make it easy for you to take raw data and turn it into calculated information and even business intelligence, no matter where the raw data is located. Let's go ahead and get started. For this class, we're going to be using the new home improvement database that's at the member portal at nioxus.com. If you'd like to download that database now and follow along, or download it after the class is completed, go ahead and go to www.nioxus.com and log in to the member portal. Whether you have a free membership or a paid membership, you can access this template. If you have a free membership, go to the template section and download the new home improvement database that appears at the top of the menu. If you have a paid membership, go to the solution template section, and there you also will find an unlocked version of this home improvement solution tool that we've built for you to use. So what we want to do is we want to find some easy ways to access data that is not necessarily in the table that we're working on at any particular moment. Let me show you an example. We have here a parent table, which is our projects table. Specifically, this is the activity, job, and project table. This table has a child. It has this project area child table where we have the details of the 4 sections in this particular home improvement project: the kitchen, living room, master bedroom, and the outside landscaping. Each of these 4 areas consists of a defined space or square footage. We have a dollar budget for materials, a budget for hours, and an estimated total cost. And here we can track our actual costs as we write the checks and spend the money on the project. There's also a second view here, which is the photo album. There are a number of functions built into Ninox that allow us to manipulate the data we see. For example, here we have our dollar budget. We have a specific number allocated, budgeted for each of the 4 areas of our project. If I wanted the sum total of all 4 area budgets to give me the total budget for my project, I could simply click on it, click on sum, and there we see $22,480, which is the additive sum total of these 4 numbers. If I wanted to know how many areas were in my project, I might go to the description column and count the number of entries. And if I wanted to know the average square footage for all of the 4 areas of this project, I could click on square footage and take the average. So we have 4 areas with a total budget of $22,480 and an average square footage per area of just a little bit over 338 square feet. These functions are built into the Ninox system itself. They're easily accessible by clicking on the column heading of any embedded view or child view and selecting the function as it's presented here in the window. The problem with this is if we have limited space top to bottom, this adds yet another row to our embedded view. Note that if I uncheck these options, that row at the bottom goes away, taking up less space top to bottom vertically on my screen. Here we see the same calculation, $22,480, which is the total cost project budget. We know this to be the total of this column, but we didn't put it right at the bottom of the column. We moved it to an entirely different area of the screen. Let's see how we did that. We're going to go in and take a look at this formula field And we're going to see that it consists of two things. First, a definition of what we want to work on, and then a definition of how we want to work on it. What we are going to do is take all of the dollar budget field contents in the project area records related to this parent, to this project, and sum up the values that appear in those 4 fields. How do we know there's 4 fields? Because there's 4 child records, 4 project areas associated with this particular home improvement project. Let's build the formula from scratch. First step, what is it that we want to work with? I'm going to go to my project area database, in this case, my project area table, which is the child table to this project parent. And I'm going to specify the dollar budget field. By clicking on dollar budget, Ninox lays down the path, the name of the table, the name of the field within the table, and the period that separates the two. This tells Ninox where to go to find the raw data that I want to work with. The next step is to tell Ninox what I want to do with the data. I want to sum it up or add up all of the values that appear in all of these fields in all of the child records in this child table related to the parent. We click OK once and twice, and there we have it, $22,480. What if I wanted to have the estimated dollar cost per square foot? I want to take an average across the entire project. Again, I could click on the column heading and calculate the average this way and find out that it's exactly $14.23. Or I can use the steps we just learned to say, go get this data in this different child table and manipulate it using this mathematic formula or this mathematic or statistical operation. Let's do that. Let's create a new formula, and let's first identify where the content is that we want to work with. It's in the project area, and it is the estimated dollar budget per square foot. Now we have a path that tells us where to find the raw data content that goes into our calculation. Now we simply tell Ninox what the calculation is going to be. It's going to be the average of those numbers, average cost per square foot. What is the advantage of doing it this way as opposed to putting it here? Well, first of all, by taking it out of the embedded view takes up less space. Second of all, by creating it as a formula, we can manipulate how it appears. We can make the text large, center it in the field, make it appear in blue text on a white background with a solid, thin black border, and we can now put it any place we want. And I'm going to put it right here where that space used to be. Now, we already had the calculation here, but I wanted you to see how we were able to run the numbers. Let's look at some other things that we can do. Here we have our photo gallery table. As we can see, the photo gallery is a separate table in our database. It is not a child of the parent project table, but as we can see by looking at the data model, it is most certainly related. Here is the project table. The project table has a photo gallery, and each area of our project has its own photo gallery. And what we want to know, how many photos are in the photo gallery for this particular project. But instead of adding up the 5 photos here, which I did by clicking on the column and selecting count, which I'm now going to unselect, I want to add a column here in the project area, knowing that each project area has their own photo album. And we see as we scroll through the 4 areas of our project, here at the very bottom of the screen, we see that there's 1 photo for the master bedroom, 2 photos for the yard, and 1 photo each for the kitchen and the living room. I want to know how many photos there are for each area in my project. Not just 5 total photos, how many photos per area. Let's look at how we can do that. First, we're going to select the embedded view. And we're going to edit columns in order to add a new column. Anytime you are doing a calculation, this is very important, anytime and every time you are doing a calculation or a mathematic or statistical manipulation of content that exists somewhere else, it's always going to be done in a formula field. So let's go ahead and grab our formula field, and let's go in and create the formula by clicking on the formula field and first giving it a name. This will be the column heading, and I'll just call this number of pics per area, number of pictures per area, and I'll click on the formula field to open up my formula text editor. And what I will now do is I will indicate first where is the content I want to work with. It's right here in the photo gallery. And what do I want to do with that content? I want to count the number of records. Ninox is doing a lot of the hard work for us. Because of the relationship that exists, that was built into the data model, we see this related table, this photo gallery table. And the nature of the relationship is such that Ninox will only count the records related to this particular area of our project. So I'm going to click OK once, and twice, and finally a third time. And as we talked about in the previous video, remember, whenever you add a new field on the right-hand side, you got to drag over to make room for that new rightmost field. And there it is. We knew when we took the count of this column, there were 5 photos. But now we see where those 5 photos are. We defined a path that said, go to the photo gallery for this particular area and count the number of records that are related to this area. There is 1 record each for the kitchen, the living room, and the master bedroom, and 2 photographs for the yard. Now we know not only how many photos are associated with this project, but where we can go to find them. This ability to manipulate data that is not part of the table that you're currently working in is a very powerful component of the 3-dimensional or relational system that is the Ninox database. But it goes further than that. In fact, you can utilize data in any table, anywhere in your database, whether it's related to the table you're working in at that time or not. Let me give you an example. Let's save the changes we made and exit administrative mode. And now let's go look at the inventory. These are all of the things that we have purchased that are going to be used. These are the materials, the pieces and parts that are going to be used during the course of our construction project. And I'm just going to make that column a little bigger there. And we can see that these purchases were made over a number of months. 2 purchases in the month of April, 1 purchase in the month of June, 2 purchases in July, all in the year 2019. What if we want to be able to build a dashboard to summarize our purchases by month? A couple of ways we can do that. And in this example, I'm going to do this using an entirely new table, which I'm going to call the dashboard. And I'm putting that in all caps so you can see that this is the new table. And I'm going to put 2 fields in this table, both date fields, one called beginning date, and the other one called end date. And I'm just using all caps to try and make it a little bit easier for you to see on your screen what's happening on my screen. We're going to save those changes, go to our dashboard table, and open up this new record. Now the first thing I want to do is skinny up these fields. They're taking up far more room than they need to. I'm then going to embed a space to close up the rest of that line and a second space to give me some area between the top parameter section and the bottom result section of my table. Which brings me to the next important component in my dashboard. I need some place to show the results, and those results are going to be shown in a view. A view, as I've said in a number of previous training classes, is your window to the rest of the world, the rest of the tables, and the rest of the content in your database. You will note, and I'm going to save my changes and quickly go look at the data model. Here is this brand new dashboard table that I just created. It has no relationship, child or otherwise, an inner join or an outer join. There is no relationship between the dashboard table and all of the other tables that make up my home improvement solution. And no relationship needs to exist because of this powerful component called the view. This is our window to the rest of the tables, the rest of the world inside the home improvements database. Now, what do we want to see through our window? We want to see all of the inventory that was purchased, but we only want to see it if it was purchased within the period of time defined by the beginning date and the ending date. We want to have some user control over what we see. And we're going to do this with no relationship necessary. Back to the dashboard table, let's just take one more check. Remember that path? Just because there's no link, in fact, especially because there's no link, the path becomes particularly important. So let's look at the path that we're going to use to get to the data that's going to be so crucial to the operation of this user configurable, user definable dashboard. It starts with the table, the inventory table. And within the inventory table, we have this field called acquisition date. We know that a path is defined as the name of the table, a period, the name of the field. So let's just keep that in mind as we now build this system dashboard without using any relationships or connections. We are going to name this our purchase ledger. And now let's go ahead and build the formula for this view. Again, remember your two steps. Define the path where the system can find the data you're working with, and then indicate what you want to do with the data that you find there. Because this is a parameterized query or selection, let's first define our parameters. And I'll do this, as I always do, using a couple of variables. One variable storing the content of the beginning date field, and another variable storing the content of the ending date field. But remember, before you can refer to a variable, you must create that variable or bring it to life using the let statement. So there we go. We now have defined and brought into existence two variables, x capital BEG for the beginning date parameter and x capital END for the ending date parameter. Now let's build the query. Select inventory where the acquisition date is greater than or equal to the beginning date and the acquisition date is less than or equal to the ending date. So we have used this path concept, but because there's no relationship, no link between the table we're in, which is the dashboard table, and the table that contains the content we want to manipulate, which is the inventory table, our query, our definition of path looks a little bit different. We use the select statement to identify the table that contains the information we want. And then we use the where clause to indicate how we're going to control via these parameters the content that we see. We're not going to manipulate the content. We simply want to select it and present it on screen. Let's go ahead and do that. I'll select OK once and twice. I'll save my changes and let's see if it works. I'm going to say that I want to see all materials that were purchased between April 1st of 2019 and April 30th of 2019, and there they are. Total purchases of $858.50. Now I know that because I added these two fields up in my head. So if I want to know how much I spent in April, there's the answer and the detail behind my answer. How much did I spend in June? Let's just go in and enter the dates to be June 1 through June 30th. And I see that I spent only $50 on one purchase. Now, when you have this few lines in the results table, this embedded table here is my results table, it's easy to just look at the results and calculate the values. But what if I had purchased 50 different things between 6/1 and 6/30? It would not necessarily be so easy to do the adding in my head. I could go into administrative mode, click on the column heading, and sum it up. That would be one way to do it. Or what I could do, and I'm going to undo that, is I could build a formula that gives me the answer in nice big bold text right at the top of the screen. Let's do that, and let me show you a shortcut how to do it. First, go back and grab the code that you used for the results table. These 3 lines of code right here, and I'm going to copy them. Now, what did I tell you about the mathematical or statistical manipulation of raw data? It always happens inside a formula. So let's create a new formula. And let's paste the data that we just found. And I'm just going to add a couple of pieces of text to literally repurpose all of this code. The first thing I'm going to do is create another variable. Let the variable called my selection equal everything that gets found according to this statement. And then what I want to do, using my path, is define a path that says, within that selection, I want you to bring up the total cost field. Again, what are the 2 steps? Step 1, define where the system should go to find the data it's going to manipulate. Now in this case, the inventory table did not appear here in the left-hand panel. It didn't appear because it's not related to this table. There is no relationship between the table I'm currently working in, my dashboard table, and this table, the inventory table, that contains the data I want to manipulate. So I had to build that relationship using this select statement. I qualified the selection by limiting it only to those records that had an acquisition date on or after this date and on or before the ending date. That which was returned, the answer to this question, or the results of this selection, were stored in a variable called X selection with a capital S. You could call the variable anything you want. This is now an array. every record in this array has one field called total cost. Therefore, this is the path that I can instruct Ninox to walk down to find the raw data to manipulate. And what is step 2? Tell Ninox how to manipulate it. And what you get back is the total for that field. We want to go ahead and name this field total cost per period. Because it is a formula, I can format it to look any way I want. And I want it to be dark blue on a white field with a black border. And because it's a formula, I can put it anywhere I want. And there we go. If we change our selection by, for example, going back to April, there is the $850, and the $8.50 added up. And if we want to look over a span of time greater than a month, say from the 4th month, 1st day, to the last day of the 7th month, here's everything we've bought, and it all adds up. These 5 numbers all add up to $2,833.50. What did we do? We used the view as a window to the rest of the world that is our database. And we defined parameters that the user could fill out. In this case, the parameters are the beginning and ending date, which define a period of time in which the purchase was made. And we told Ninox, go there and find every record in that table, in this case, the inventory table, where the value in this field, the acquisition date, is on or before this ending and on or after this beginning defined period of time. We then copied this code because now we have a selection of records. We created a new formula and we manipulated that selection of records by storing it in a variable. This variable now contains an array or a selection of records from the inventory table that meet this defined criteria. And we said summarize, add up all of the values in this particular field within all of the records within that particular array. Step 1, tell Ninox where to go to find the raw data you want to manipulate. And step 2, tell Ninox how you want to manipulate it. Want to know the average cost of all of your purchases? Copy the data simply by right-clicking and selecting copy. Select a new formula. Paste the content and change the manipulation. And now we know that of these 5 purchases, the average cost per purchase, and I will format this as I did the previous field on a white background and place it right there. So now we can see that over the period of time from April 1st through July 30th, 2019, we spent just a little over $2,833. We made 5 purchases, and here are the line item details of those 5 purchases. And those 5 purchases average out to just almost $567 per line item purchase, the average of this column right here. We are able to use our path to define the location of data we want to manipulate. That data may be in a related table that is related by virtue of a child-parent relationship. That's what we saw here, where we have the child, and here on the parent screen, a manipulation, a mathematic manipulation of data within the child table. We can manipulate data that is in a table that's related but not a child. We saw that when we counted here the number of photographs in the photo album table or the photo gallery table, we put the sum total of the count, how many pictures are there per area, in the child, and within the child, we counted the number of records here in this related table, but not related in the same family. It was an outer join. We see that by noting here that this photo gallery table stands alone. It's not embedded underneath this activity, job, or project table. Therefore, we know it's not a child. But there is a relationship. And then we went the next step. We created an entirely new table for which there was no relationship to any other table, inner or outer, child or otherwise. And by simply modifying the way we defined our paths, we set up a view which became the results of our query. We set up parameters which were the contents or the definition of qualification for the query. You must be within this date range to appear in this screen. Change the date range, and we change what appears. And then finally, we created two tables using that, give it a path, tell it how to manipulate what it finds at the end of that path methodology for knowing the sum total and the average of the totals of the records that appear in this particular table. If we wanted to get really fancy, maybe we would have added a drop-down or a choice field with the names of all of the vendors we bought from. And we could have specified the name of a vendor to see how much we bought from each vendor within the defined period of time that we see here with the beginning and the ending date. And that is how we can very easily manipulate content or raw data that's not necessarily in our current table, but is the input for calculations that we want to appear in our current table. The current table here is dashboard. The data in this inventory table is the input for the calculations that give us these summary numbers, total and average, right here. As we saw in the parent, the child, and using the outer join, the number of photos can be mixed and matched. We can go into the child and count the number of photos. We can go into the parent and count the number and average dollars within the child, all by simply specifying a path and defining a function that we want to execute against the data that appears in that path. And remember, some functions might not necessarily be mathematic. For example, we may want to know the date of the most current picture of all of the photos associated with this particular project. We know there are 5 photos. We know there is 1 photo for each area, kitchen, living room, and master bedroom, and 2 more for the yard. But what I want to know, and I want presented in this space right here, is the date that the most recent photo was taken. Where do we compute this information? In a formula. So we're going to grab a formula, and what do? First, we tell Ninox where to find the content that it's going to manipulate. It's going to be found in the table called Photo Gallery in the field called Date. There is our path. Table, period, field. And the second step is to simply tell Ninox how to manipulate what it finds at the end of this path. Find the one date, the one value in the one date field in this table that is the max, the highest, the most current date, and present that date, which we will call most current photo date. Size it up, place it where we want it, and there we go. The most current photo happens to be taken on August 9th, 2019, and that is this photo of the yard. If this photo of the master bedroom had in fact been taken on February 26th of 2019, that would not change the date. But what if it was taken on February 26th of 2020? Now all of a sudden, that becomes the date of the most current photo in the photo album. So you can use not only mathematical and statistical calculations like sum or average, but you can also look for the min or the max, the first or the last, when you're evaluating non-numeric data. The date is a specific point in time. And using the max function allowed us to find the highest, the maximum, or the most recent point in time across this selection of 5 dates right there in the photo gallery. And that's all there is to it. Whether it is a child table or a related table linked with an outer join, or a table for which there's no link, no relationship whatsoever. Define your path. Tell Ninox where to go to find the raw data you want to manipulate. Then put that path in parentheses and tell Ninox how to manipulate it. Add it up, use the sum feature. You want the average, lowercase avg. That will give you the average. You want to know the first or the last date, the min or the max of an array of date fields. I think you'll find this easy method to be a powerful way to enhance your Ninox projects with dashboards and scorecards, user-defined parameterized searches, and the ability to go in and see what you need, the way you want to see it, formatted, placed where you want it, right on the screen. I hope you enjoyed this video, and I thank you for joining me in this class today. Make sure to come back next week when we'll have a whole new class right here on the Ninox Learning Channel. On behalf of everyone here at Nioxus, thanks for joining me today. Have a great time with your Ninox database, and please do come back and join us soon. I'll see you in the classroom. Bye-bye, everybody.